Let's jump right in. Welcome to this explainer. Today, we're diving into a genuinely fascinating piece of technology. It's called the Codatta Protocol, and we're going to use our time together to unpack exactly how this system solves what's arguably one of the biggest paradoxes in our digital world today. It is literally a breakthrough for anyone out there who wants to ensure their work is recognized without, giving away all their secrets. Think about the current landscape. If you're a creator, a researcher, or a developer, right now, you're basically facing a terrible choice. You can hoard your proprietary datasets, maybe your medical research or your trading algorithms, on a super secure local hard drive. Sure, that keeps them safe, but it means zero credit, zero collaboration. Or you publish them online, right? You claim your rightful attribution, but then you risk having them instantly scraped, stolen, and monetized by someone else. You shouldn't have to choose between getting credit and staying protected.
Okay, let's dive into this, because this brings us to a really fundamental question. Can data actually be public and private at the exact same time? In the blockchain world, we're dealing with this massive inherent conflict. On one hand, blockchains are fundamentally built so that everyone can see everything, right? They're distributed ledgers completely based on radical transparency, and we love that trustless environment because you don't need a middleman. But on the flip side, as users and builders, we have this desperate need to keep our own sensitive data totally secure and hidden from prying eyes. Whether we're talking about a massive database of user behavior or a highly sensitive proprietary algorithm, you simply can't post that raw data to a public ledger. No way! So, how on earth do you reconcile a fully public network with the absolute necessity of personal privacy?
Well, this sets up a true structural tension: on-chain transparency versus off-chain privacy. It's kind of like looking at two entirely different worlds. The on-chain world, it's loud. It's basically a public megaphone where every single transaction, every wallet address, every record is broadcasted for the entire globe to verify in real time. And that transparency is what brings unparalleled security and consensus. But off-chain data, that's secretive. That's your private database, your enterprise server, locked away tight behind firewalls and heavy encryption. For the longest time, the blockchain space basically forced you to make a binary choice. You either got the trust, immutability, and transparency of the public chain, or the security, secrecy, and high performance of keeping things strictly off-chain. You are always sacrificing one for the other. And honestly, that heavily limited how useful blockchain tech could actually be for complex, real-world data.
So the crucial point here is we actually don't want to choose anymore. We want both. And that brings us to the core concept of our explainer today: privacy-preserving transparency. I really want to emphasize that phrase, privacy-preserving transparency, because it is exactly what the Codatta Protocol finally pulls off. It acts as this incredibly elegant, highly functional bridge between those two historically polar opposites. Instead of forcing a compromise, the protocol manages to completely resolve the paradox. It gives us the absolute best parts of public ledgers, the verifiable trust and permanent attribution, while maintaining the absolute safety of private data. Honestly, it's a paradigm shift. It completely changes the rules of the game for anyone dealing with valuable digital assets.
The core philosophy here boils down to one really powerful idea: making knowledge traceable and ownable without revealing its content. Think of this protocol as the ultimate digital safe deposit box. Let's say you go to a secure bank. The entire public network, the tellers, the security cameras, they all know you walked into the building, right? They know you want a specific vault, and they can see the exact timestamp of when you put a secure briefcase into it. That action is entirely transparent and 100% on the record. But what's actually inside the box? Is it a brilliant new software framework? Sensitive medical data? Only you and the specific people you hand the physical key to will ever know. The public can absolutely verify the existence and the ownership of your asset, but the asset itself, it remains completely opaque to them.
To make this digital safe deposit box a reality, the Codatta Protocol breaks everything down into three distinct, really seamless steps. First up, we have the on-chain commitment. Second, the encrypted payload. And third, smart contract access. Just imagine a highly sensitive piece of research you just spent, say, 2 years completing. To protect it while definitively proving that it's yours, it moves through this exact pipeline. It gets stamped, it gets locked up, and then it gets guarded. We're going to look at exactly how each of these steps functions together to give you that perfect blend of attribution and security.
All right, step one is the on-chain commitment. Think of this as acting like a permanent public record of who contributed what and when, all without revealing the actual data itself. It's essentially a permanent public receipt, or, an unchangeable name tag. Under the hood, what the protocol is doing is posting a cryptographic hash to the ledger.
It takes your massive private dataset and generates this unique, fixed-length string of characters, basically a digital fingerprint. And that fingerprint is what actually gets recorded on the blockchain. By doing this, the Codatta Protocol ensures absolute attribution, auditability, and trust. It permanently locks in the who, what, and when in a way that literally nobody can ever erase, alter, or claim for themselves. It gives you undeniable, mathematically proven ownership.
Now, what's really interesting here is that while that receipt lives loudly on the blockchain, your actual information becomes an encrypted payload. The real data stays completely hidden and is heavily encrypted off-chain. It essentially goes into hiding in a secure storage environment, and it is only ever accessible to authorized parties through programmable access rules. You basically get to act as the ultimate bouncer here, creating a highly specific VIP guest list for your data. You hold the decryption keys, so unless someone is explicitly on that VIP list, all they're ever going to see is an unbreakable wall of encrypted gibberish. You retain total sovereignty over the information. You decide exactly who gets to peek inside the safe deposit box, when they get to do it, and under what specific conditions.
And this brings us to the real genius of the architecture itself, hybrid storage. It is the perfect marriage of on-chain integrity and off-chain efficiency. We all know blockchains are incredibly secure, right? But they're also notorious for being slow and prohibitively expensive if you try to store too much heavy data directly on them. I mean, storing gigabytes of research or user data on a mainnet would cost an absolute fortune. But by keeping the massive, sensitive payloads off-chain, the system remains lightning fast, incredibly scalable, and perfectly private. Yet because the cryptographic proof, that unique digital fingerprint we talked about earlier, lives permanently on-chain, you still get that rock-solid guarantee that the off-chain data hasn't been tampered with. It's the ultimate hybrid engine. It gives you the security of decentralized consensus, but with the speed of traditional web storage.
And this brilliantly illustrates the final piece of the puzzle, smart contract access. Because how do you actually enforce those VIP programmable rules we just talked about without relying on some centralized company acting as the middleman? Well, you don't use a human security guard, you use smart contracts. These are automated, unbreakable lines of code living directly on the blockchain. They combine that on-chain integrity with the off-chain efficiency to strictly and automatically enforce access. Just imagine a rule that automatically grants a research hospital access to a highly sensitive medical dataset, but only if they hold a specific verification token and pay a required microfee. The smart contract handles that entire transaction seamlessly, no humans required. This means you have secure and incredibly flexible data usage across a massive variety of complex, real-world use cases, executing exactly as you intended, every single time.
So let's pull all of this together. Why does the Codatta Protocol actually matter for you? Well, we now have a reality where contributions are permanently recorded on-chain, yet the real valuable data stays entirely private. Your knowledge, your hard work, and your proprietary assets are strictly traceable and entirely ownable. And because of the power of smart contracts, you get secure and highly flexible data usage without ever needing a centralized authority. The big takeaway here, that old paradox is broken. We no longer have to sacrifice our privacy just to get true attribution and trust on the internet. You can own your work, mathematically prove it is yours to the entire world, and keep it incredibly safe, all at the exact same time. It's a real game changer.
And that brings us to a final, provocative thought to leave you with today. How will you take control of your digital contributions in this new hybrid future? As we move toward a web where you can truly own your traceable knowledge without ever having to give away its contents, the power dynamic fundamentally shifts back to you, the creator, the researcher, the contributor. It's a massive leap forward in how we handle valuable information, and quite frankly, it's just getting started. Thank you so much for joining me on this explainer. Keep learning, stay curious, and I absolutely cannot wait to see how you secure your own piece of the digital vault.